Welcome everyone to our virtual roundtable on enterprise application security. We're excited to be here today to talk about the latest trends and best practices around this critical piece of managing your software products. My name is Jesse, and I've been working in tech since the 90s. I'm currently serving as the Chief Technologist here at DZone. I got started programming Java, and back then, application security was a huge topic, but primarily focused on monolithic applications in a client-server architecture with well-defined borders that you could protect. As we'll see today, that is drastically different from today's mega-scale, microservice, single-instance, multi-tenant SaaS applications running in the cloud. Now, we've just released this latest trend report on enterprise application security that you can download on DZone.com. This is the perfect place to go to get updates, best practices on products, architecture, and tech trends, trusted by millions of developers, architects, and tech leaders just like you every single month to keep them up to date. Now, I'm excited to get started, but if you'd like to send this to a friend or watch other events like this, just go to dzone.com/webinars so you can see all of our on-demand recordings. Now, I'm excited to introduce our panel of experts as we get started. First of all, Eric Koslow, Senior Director of Product Management at Azul. Thanks, Eric, for being here, and thanks for the sponsorship. Roderick Chambers, where's Roderick? Wave, Senior Information Security Specialist at Recorded Future, who wrote Building a Tailored Guide for Handling Security Incidents in our trend report. So thanks, Roderick. Justin Albano, Justin, Software Engineer at IBM. Software Supply Chain Security Checklist was your article, so thank you for that. And Julie Tsai. Julie, wave, cybersecurity leader, board member, and investor advisor, and wrote DevSecOps Easter eggs, which was a great addition to our trend report. And a very special thanks to our sponsor, Azul, and a huge thanks to each of you panelists. So I want to start us off looking through what our trend report covered, right? Enterprise application security, we could talk for 4 hours. We have in the neighborhood of 40 minutes, right? So everybody here is familiar with OWASP, right? And in 2021, OWASP surveyed and identified the top security risks to applications. In our survey, we asked developers to rank these based on their own experiences. Now, according to our devs' experiences, the top 3 problematic application security risks: number 1, broken access control. Number 2, identification and authentication failures. And number 3, insecure software design. Now, my question to you all as a panel, first of all, based on your experiences as a security practitioner, would you rank these as the top 3, or is there something you feel like we missed? And Roderick, why don't you go first? What do you think?
Definitely. I definitely would rank those as the top 3. I'd also like to list a priority one as well, too, which is going to be the insecure application development. The way I look at this is, since COVID, and a lot of mobile and web applications have just been launched, a lot of startups, a lot of ways for us to really move away from the human-to-human connection. We have apps everywhere. It's the speed of business. When I look at things from a compliance point of view. So HIPAA, for protected healthcare and patient data. Look at PCI compliance. How do we protect those? And based on the software development lifecycle and getting those applications out very quickly, we just sped up the process. So we miss certain things, just like cross-site scripting errors or SQL injections, or just a lot of developers really running a lot of sprints trying to get an application up and running as soon as possible. And we leave things such as on GitHub, on code repositories, and administrative panels. And so that design, I think, is really one of the key contributors to a lot of the attacks that we've seen here, the breaches that we have. But those 3 are absolutely perfect. I just think that speed of business causes speed of attacks to increase as well, too.
Okay, awesome. Eric, what do you think?
Yeah, I mean, I would put insecure software design probably as my number 1, because ultimately, if you don't design security in, it's really hard to bolt it on later. And this also deals with the organizational structure of how an app dev team works with an ops team, works with a central security team. So to me, that's the most important, because it has the highest impact on an organization. Otherwise, I do see why broken access control and authentication are pretty high on the list, because over the time, as I just use different services, I unfortunately see a lot of backend APIs where the REST service authenticates you, but doesn't authorize you. So you can just crawl through pretty much everyone else's data in a lot of backend services. It's kind of disappointing as an industry.
Very cool. All right. So now I'm going to go to Justin, but I'm going to give you a new one because what Eric just said made me think of this. So also in the survey, we asked developers, at what stage in the software development lifecycle does your organization first implement security? Right. So back to what Eric was just saying. But what's interesting is the 5 stages ranked. Number 1, development and coding, which is in line with what we want to hear. Testing, integration, design, planning, analysis, maintenance, and 7% responded they don't know. Right. So do you agree with the ranking there? And how about your experience in your software development lifecycle at IBM, right? Big Blue, you've got a lot of process. And, you know, do you agree with that's where we should start? And do you do that?
Now it's interesting because the ranking is probably more in line with what actually happens compared to what should be happening. And I think that's right. I think most applications probably get their security put in at the implementation or your like fingers to the keyboard level. But as Eric said, a lot of that security needs to be built in way ahead of time. That's even before you get down to like which components go back and forth with each other. There's different types of security too that you can implement at a design or architecture level. Like for example, how much data flows from one component to another, what type of data is flowing between, let's say, your database and your services that communicate with your database. Does that data need to be secure? Does it need to be put in plain text? Does it have to be encrypted? All those different types of decisions are going to be difficult decisions to be made at the implementation level. But from a practical point of view, kind of, you know, how do you get here from there? That's probably right. That's most of the security gets put in at the implementation level.
Okay. All right. Well, there's another thing that I wanted to ask the panel. So we talked a little bit about OWASP and the rankings that the developers gave for application security, right? And that's broken access control, identification, authentication, insecure software design. We talked a little bit at Eric's prompting about shifting that more left. We'll talk about that in just a second. But it's different. The top 3 that I just listed are different than what OWASP's top 3 were. Broken access control was number 1, but they had, instead of identification and authentication and then insecure software design, which we were just talking about, they had cryptographic failures and injection. Now, based on your experience, why do you think those are different? And Justin, why don't you go first?
Sure. From a cryptographic point of view, that's it's almost a running joke within development circles about people creating their own cryptographic functions or trying to do cryptography on their own. And it's conceptually, a lot of times cryptography is pretty straightforward. Like you learn about sharing keys or you learn about certain exchanges, but implementing it is a completely different story. And personally, I'm not a guy who does cryptography every day of the week. So for me to implement a cryptographic function or me to do cryptographically safe hashing that's out of my ballpark. So what ends up happening a lot of times is instead of using a library that's been vetted and basically scrutinized year over year, a lot of people just introduce their own, you know, almost like a hack of a cryptographic function. And it ends up basically embedding a ticking time bomb in a lot of products, because as people chug through these products or as people brute force them or throw every attack vector you can think of at it, a lot of those places that those little hacks end up are the first places to break.
Yeah. And when I think a little bit about software development lifecycle and this whole shift left thing that we were talking about, right? If you've got developers that are working to write their own cryptographic functions, right? I feel like we didn't do what Eric was just telling us we should do, right? Push that thing as far to the left in the design phase as possible. So what are a couple of, Eric, you can go first. What are a couple of practical things teams can do to implement that and get that where it needs to be? I mean, what are we missing? Because we're obviously missing something.
Yeah. So in terms of cryptography, I actually have a course on Pact Publishing that's about doing cryptography in Java, because I used to run one of the major root certificate programs. So I think one of the best things in terms of cryptography is just to recognize your shortcomings and that you should not be writing the algorithms themselves. In the world of cryptography, there's a lot of expert mathematicians and university professors who all they do all day long is go and nitpick with each other and debate and argue about even the tiniest, smallest merits of every single thing. And you just show up at the end of those discussions, take the algorithms that they've created, follow like an NSA Suite B, and just figure out how to apply those. Like, how am I going to encrypt this? I'm going to take all the work that happened at the end. I'm never, ever going to go implement my own cryptographic libraries. That's a really bad idea. It's one of the reasons why in Java, I like the fact that there's the Java cryptographic architecture, that I can just take advantage of stuff. Never, ever am I going to build my own crypto system. Not a chance.
So you heard it here. All you developers out there, stop building cryptography. One, because we're not as good at the existing libraries. And two, it messes us up. And I do want to go back and think a little bit about, so we talked shift left. I do want to jump over and get Julie's thoughts on the DevOps side, right? So we got shift left, but at the far right is a DevOps team, right? We have DevOps, which is oftentimes like the last bastion, the last gate, if you will. And as we talk through this stuff, it's super interesting. We talked a little bit about in the trend report, the Uber driver, Uber's developer who stored all of these credentials to company apps in their GitHub repo, in a private GitHub repo that led to 57 million user and driver account compromises, which is devastating, can be devastating to these companies, right? And so when we talk about making sure that we have security through the whole software development lifecycle, talk to us, if you will, for a minute about the DevSecOps at that last end, and how DevOps, is starting to add in the security and help catch things that were missed earlier in process.
Yeah, absolutely. I often like to say that DevOps and DevSecOps are kind of a Rorschach test for companies. It kind of indicates what the value system is of the company is, because in some ways, if people are implementing DevOps and DevSecOps correctly, you're training your developers in the beginning, you're having good credential management from the beginning, you're not letting these things go to production without knowing, where things are, or that that people are managing their own credentials well, like that there's not you have different credentials for your production critical systems versus your development systems, so right. At the heart, those things should be happening throughout the life cycle. But what actually ends up happening in practice is a lot of time DevOps teams and DevSecOps teams get thrown in at either the deployment or at the last mile stage, and going in there to clean things up. And, better something than nothing, right? But at the same time, the stakes at that point are very high. One of the reasons that we always try to get people to shift left in their implementation is that idea of an ounce of prevention is worth a pound of cure, right? That you're going to be able to do it early on. But security is a weakest link in the chain problem. So really, when you start looking at where companies get pressure tested and where things start breaking, what you actually see is what was the area that the company was neglecting the most, and that's what surfaces. But it really illustrates the fact that all it takes is one mistake, and sometimes a benign mistake, something that people weren't thinking that hard about, kind of assume they've been going on forever without ever having an issue. And luck goes the wrong way that particular time, and you got huge ramifications for your users and your company.
Yeah, and a cost, right? I mean, maintainability. Right. You look at maintenance costs, and a couple of really bad bugs go right back into the beginning of the system. So I totally get it. And then performance. Sometimes security issues affect performance, and DevOps gets blamed, right? I mean, absolutely. It all starts with, hey, spin me up another VM. Or, add in another auto scaling, auto healing, something. They think DevOps is magical. And it is, right? For those of us who were putting machines together in a physical place, it is magic. And it's great. But I want to jump over and think about whenever we've got considerations in the design phase. And Roderick, I'll throw this one at you first. There's three things that we're going to be asking developers in our survey to rank. And the top three considerations for app development were security, maintainability, and performance, right? What do you think about those? Do you think that's the right order, or would you change anything?
You know, based on that order, I think as a good developer, they're sitting there, they're going to say that order. But also look at I get to see the post-mortem of things, you know.
Yeah, sure.
Where did we go wrong? Where did we have? And if you really look at some of the applications that we have in the security, yes, we all want security in mind. We always want that to start at the very beginning of the process and ongoing throughout the life cycle of a product. You're gonna have updates, you're gonna have updated versions, your client base is gonna expand maybe beyond your current geographic boundaries, but also funding comes into play as well. You know, when you're starting off with a startup, you know, you might use some components that have known vulnerabilities. Why? Because we can afford it. Apache, free software. A lot of people use Apache, has lots of vulnerabilities. That's all we can afford at the moment. But once you start getting that Series A and B and C funding and you get more investors, you're able to bring in really good coders. I always look back and take a look at, you know, what developers did we have? Do we have contractors that were there? Were they, you know, moving back doors? How do we save the files? As your web application gets better for maintainability, you're able to maintain a little bit easier. Performance, meaning uptime. People are using your app, you're getting money. Then security comes into play. You get better tools, better components, updated versions, a private code repository instead of using the standard public GitHub, more specific contractors with better access and credentials that they have there. So when we talk about shift left, I kind of think we're going to be shift left the entire time. While security is number one on that list that developers would say, they're supposed to say that. I like that they say that. Now, what can they really do that at the time? It becomes, you know, a little bit of, you know, hit or miss. But as the company, as the web application develops and grows, maintainability, usability for customers, security has to be, again, at the beginning of every stage again, reviewing the code, reviewing the process, reviewing the admin credentials. That's where we look at.
But hold on, are you saying, if you're saying what I think you're saying, you expect the order to change based on money?
Yes, it is going to happen.
Okay, I'm just calling it how I see it.
It's going to have to. It's going to have to. A lot of our best apps
I got to go to Eric and Justin. And I got to go to Eric and or Justin. Do y'all and Julie, do y'all agree with that? Do you think and it's a great, look, it's a good devil's advocate question, right? Is it right for security to always be at the top? And then is it practical for a company based on money? You brought it up. I love it. So what do y'all think? Somebody jump in.
I mean, is it right for security to be at the top? Yes, it's right. But does that actually happen? I don't think that actually happens. Oftentimes I've heard the phrase security isn't a priority until it's the only priority. So what you'll find is that everybody will say, security is priority. That's literally one of the phrases that appears at the majority of breach emails. Security is our top priority. Your security is important to us, right? Like when you call and get put on hold. So oftentimes it's done late or not at all. And one of the things that Roderick was talking about is the concept of different types of developers, where some are contracted, some are in-house, some are elsewhere, some things you get from vendors. So yes, we have this notion of shifting left with all the security controls of doing it early and in the design phase. But remember, DevOps is drawn as a circle. So every time you shift left, you need a corresponding control to the right to make sure that it actually happens. You told me that security was your number one priority. What control do I have to validate that it actually was?
Good. I like the idea of the balance, right? Justin, you agree with that?
Yeah, and like I was mentioning before, there's definitely a difference between how things should be and how they end up being based off of just schedule constraints, budget constraints. Sometimes it's just as simple as developers having an off day, or like there's all this human factor part of the development that goes into when security shows up and how it shows up when it actually does.
Very cool. All right, so we're gonna go back to Julie a little bit, since we're now kind of in that DevOps, that other side where you live. I'm curious to see how organizations are utilizing these pipelines, these DevOps pipelines for application security. So we posed this question in our survey: which of the following tools and tests are integrated into your DevOps pipeline? Right here are the top three responses: a Chaos Monkey, right, or some similar service, and that was 55%. Dynamic application security testing, 44%, and then dependency analysis, against CVE lists, right? So I'm hoping that's some kind of an automated, maybe Maven against something. But top ranking Chaos Monkey increased to 55% from in the 20s, like 27% last year. So chaos engineering as a factor in DevOps integration, is this playing out with what you're seeing at other companies, Julie, and in the real world?
Absolutely. What I think is great about chaos engineering is it's a great way to get your other stakeholders and departments at the table and potentially have a cross-functional fun exercise. I think the reason you're seeing it pop up to the top of the list is if you compare the level of effort involved for the organization for each of those things. Chaos Monkey, honestly, aside from the timing of the event, it's a little bit less, it's much less costly to just give someone a command to randomly break something versus, hey, we're going to go through and catalog and instrument all of our dependencies and just do it right from the beginning, which is, what you need to do to really get good software supply chain. But, when companies are looking at hey, if I have this thing that's that's low hanging fruit, and we can have this good rah moment of with the team, and I'm not opposed to it. I think it's awesome. It's great.
Yeah.
But I think the companies that are truly mature and well instrumented, well disciplined in their whole security pipeline are going to come out well with the Chaos Monkey. At some of the companies I've been at, we would joke we have organic Chaos Monkey just because of our technical debt. We don't have to really, create another one. It happens naturally,
Yeah.
But it's always a good thing to take those fundamental good incident running postmortems and look through the entire pipeline. It's just, if you're going to go at it with integrity and seriousness, you really have to say hey, are we going to really attack the hard stuff or not?
Yeah. And some of those companies, I've worked in one that had a Chaos Monkey. It was because of some accidental architecture that we had on the design phase. So yeah, okay. I'm here for it. Now for the rest of y'all, are there any tools that you feel like they missed? Is there something other than those top three for Roderick, Justin, or Eric, anything that you would add into that list, especially for the devs and the teams that may be getting started on some more application security stuff? Any recommendations?
There are a number of tools that do them in the dependency analysis space. One of the issues that I have with the scanners, in particular relation to Java applications, is that Java doesn't load all of the libraries that are present. So when you go to do a vulnerability scan, you'll often find this application contains that vulnerable library. But then when you go to ask the JVM, it's not actually loaded. Similarly, during the log4j, because we have to bring that up, time frame, a lot of people tried to find the vulnerability by just going around and scanning web applications, doing dynamic scans. Well, unfortunately, a lot of Java applications are not web applications, so of course they wouldn't respond. So, I don't mean to promote directly what Azul is doing, but we just integrated composition analysis into the JVM itself so that when you run your Java applications, you get that dependency analysis inventory. What are you actually running on top of the JRE? Now we tell you.
Yeah. And those are the good things. You're getting into software supply chain, if I can use that term. Justin should grin right about now. But it's, as we're talking about that, I think it's a really good thing to consider. And now, we're talked about how we're going to pulling on that thread of scanning and using automated dependency checking and all that stuff. How quickly, I'm kind of curious on how quickly organizations address these exposures, these CVEs, if you will. And over half of our respondents noted that their organizations scan for these vulnerabilities either weekly or monthly. Okay. Now, as a follow-up question, we asked, what is the standard turnaround time for addressing these? Right? Because there's two phases. There's, hey, I'm going to scan, I'm going to figure this out. What is the list? Now we got to fix it. So, 44%-ish said that we addressed them within weeks. 38% said days, and about 8% said hours. So Justin, over to you. What do you think is, are these standard? Are these acceptable? Would you change them? What do you think? How do you think companies should respond, taking into account the product management has to build features to sell and sales cycles, everything else. What do you think that turnaround time for these CVE should be?
I'm going to give the magic answer of it depends. And the reason I say that is every company's got its own process for handling known vulnerabilities. So like you said, one of the first things you need to do is figure out, am I vulnerable to something and what am I vulnerable to? Like, what's the scope of the vulnerability? What products do we have that have this vulnerability? And then once you get that, it's from a development point of view, there's almost two parts that happen here. It's how quickly can the development team take this vulnerability and mitigate it or address it and check that back into your repository. And then the second part of this is more into the release engineering part, is how often do we send out releases? So certain products might have daily releases if they're, on the scales of like Twitter, Facebook. Those are almost instantaneous. You make a change and they just roll out a change. And there's other products that may only have a, every quarter release. So now a company's stuck with this known vulnerability for a full quarter, and they have no way of getting to their customers, or getting a fix or a patch to their customers. So there's, from a development point of view, you want to address them as quickly as possible, but this also goes into how do we release our product? And is this something that's so important that we have to release a patch in between releases? Do we have to shorten up our release cycle? So there's a lot of process, and like I said, it's more release engineering thinking than it is how quickly can I go into my code and remove this Maven dependency and check it back into the repository.
Got it. So it depends, but as quickly as we can based on our process.
Right. And there's
Awesome.
also different types of software. Like if you build the software yourself, if you're writing it, yes, you can update those. But for infrastructure software, like I go get a copy of Kafka, Cassandra, I go grab MySQL. I just need a regular maintenance window when I can actually update that infrastructure code.
Right. All right. Last question. We're down to the last few minutes. You're all security professionals, experts in the field out there getting after it every day. But I want to leave something for those viewing today, specifically from you, right? So I want you to think about what the number one security threat to applications in 2023 is. From your expert opinion, what do you think the number one security threat is? And how should developers and companies prepare themselves to combat that threat? And Roderick, I'll ask you to go first.
Oh, perfect. I'm gonna have to take the broken access controls and authentication.
Okay.
It leads to ransomware. It just really does. I mean, once you have the administrative controls and you're able to pivot and escalate privileges, that's really the big thing. And I really want developers to really take a look at that, at the access controls and authentication, ensuring that their developers are using secure coding practices, logins, I dare say MFA, that will change, single sign on everything else. And then also from a incident response point of view, build in an IR plan with your team in the SDLC process. Again, it hurts my soul when I get to the end. No, we could have prevented this 3 or 4 or 6 months ago, and we didn't do it, but we're learning after the fact of the breach. People's data is out there, either the performance of the applications out there, the maintainability of it, the developers' work is out there. If you build in that incident response plan a little bit earlier, if you can keep things going while fixing things going ahead. But authentication, access control, please do not use password 123. Please do not use airplane to football teams. Let's move beyond that, please.
Okay.
Okay.
Awesome. Awesome. All right, Julie.
Yeah, I think that as we've seen things evolved in the industry in this space, we have to get more and more precise and targeted about what we're looking at, because it is impossible to be perfect. We have to strive every day. That's important. Always striving to be as perfect as we can, but it's impossible to be 100%. And I think that data security has to be very high on the minds of the application developers, as well as CISOs, CIOs, and I would say even like CEOs and legal, because you want to focus your efforts around, what's that life cycle of the really critical data that's going to hurt your consumer, and cause major security or privacy issues, and design your investments accordingly.
Awesome. All right, Justin.
I would say take a, a holistic approach to your application. Like step back and look at your application and understand what your application's using, what dependencies. Like Eric mentioned, there's pretty effective automated tools for figuring out what vulnerabilities you have and what products are being pulled into your product, and getting your arms wrapped around what is in your product and what you're vulnerable to, I think is one of the most important first steps to understanding how do we close off these attack vectors, how do we, or what's our scope of our vulnerabilities. So I think a lot of times we almost get like too down in the weeds on specific tools or specific processes, like the one-off processes, as opposed to stepping back and looking at, do we need to have a more often release cycle to be able to mitigate vulnerabilities as they come up? Or do we have a way of finding 0-day vulnerabilities when they pop up and there's no way to know them ahead of time? So I think sometimes stepping back and looking at your entire product and looking at your entire process is a good exercise every so often to kind of, recover and figure out where you stand at the moment.
Awesome. All right, Eric, wrap us up.
Sure. One of the main things I tend to focus on is the concept of alert fatigue and communication. And so I really look at like, how can we decrease the number of interactions that people need to have to do the right thing? And then as I set up different security tooling, or as I go to rely on it, what I've seen in a lot of breaches is often the source of the breach was known, or it was identified, or the indicators of compromise are there, but there are so many alerts and so many notifications that they're all drowning each other out. So instead of adding new security processes and instead of adding new security steps, we need to figure out ways to not have additional steps, or to make them a part, an automated part of the other steps, and not constantly put the burden on a person being diligent nonstop, because they just can't do it. There are too many notifications, so we need to decrease the amount of work.
That is some great advice for everyone getting started and are working to build and improve your application security. Thanks to all of you panelists and experts in the industry for a great summary and discussion of the current state of enterprise application security in the industry. Thanks again to Azul, our sponsor, and to the authors for your contributions to the trend reports. Now, you can download this trend report on enterprise application security at dzone.com. And if you want to share this or view any of our other on-demand events, you can visit dzone.com/webinars. Please help us continue to improve by staying online for just a minute and filling out a quick survey. Thanks.